All right, so let's now look at the proofs. Prove the following identities. Cos B plus cos C over sin B minus sin C is equal to cot B minus C. All right, I told you that each time you see that we have same trig functions by different angles, already think about the factor formula. Same trig functions by different angles, think about factor formula. So I will say, okay, from left-hand side, now we have cos B plus cos C. That will now be as our proof. I'm going direct. Now cos B plus cos C, that means that it is cos P plus cos Q. And the cos P plus cos Q means 2 cos. Therefore it will be a 2 cos C, leave space there. Again cos. But in the first case here, when you're putting 2 cos, the first part, you add the angles divided by 2. The second part, you subtract the angles divided by 2. Take note of that. The first bracket, add the angles divided by 2. First bracket, add the angles divided by 2. Second bracket, subtract the angles divided by 2. So here it will be, the angles are these. So it will be B plus C divided by 2. Subtract B minus C divided by 2. That's what we have. Then for down, sine minus sine. Sine P minus sine Q, we get 2 cos sine. So it will be 2 cos sine, like that. But in the first part, you add the angles, divide by 2. The second part, subtract the angles, divide by 2. That's how simple factor formula is. You just recall that sine P minus sine Q will be 2 cos sine. 2 cos sine, but now 2 cos, add the angles divided by 2, sine. Subtract angles divided by 2, okay. And you see that this 2 goes out with that, and this cos goes out with that. So finally, what we're going to have, we shall have cos of B minus C over 2 over a sine of B minus C over 2. But generally, how do you call this? Cos over sine is the same as a cot B minus C over 2. Then we can say quite easily. Done. Let's now come to this. We have sine theta plus sine 3 theta plus sine 5 theta over cos theta plus cos 3 theta plus cos 5 theta must give us sine 5 theta. So we say from left hand side. So this will be sine of theta plus sine 3 theta plus sine 5 theta over cos theta plus cos 3 theta plus cos 5 theta. Now, I'm starting from left hand side. Now, we are going to repeat the other technique. Of 2 of them, if you add them, we get the other. So, for example, I want to consider this one. Theta plus theta is 4 theta divided by 2. You get 2 theta. Do you get this? No. So therefore, that will not work. Let's try this and that. When you say 3 theta minus 5 theta is 2 theta divided by 2 theta. So means that we shall work on this and this to get this. So therefore, we apply factor formula on these two. Factor formula here. We apply factor formula here. And why are we using factor formula there is because when you add 3 theta, subtract 3 theta minus 5 theta and you divide by 2. 3 theta minus 5 theta, you get negative 2 theta, divided by 2 will be theta, which resembles this. So therefore, we have to use this and that. And automatically, even for this and that will be true. Therefore, shall say sine theta plus, now I want to use factor formula on these two, and sine plus sine gives us a 2 sine cos. So it will be a 2 sine, okay, then cos, if you can see that. All right, but in this first part, you add the angles divided by 2. That will be 3 theta plus 5 theta divided by 2. Then it will be 3 theta minus 5 theta divided by 2. Oh, will it really give us? Will it really give us? Okay, let's proceed. So this will be now cos theta. Was there another alternative? Okay, let's continue. So this will be plus Apply factor formula here. Apply factor formula here. Factor formula will be 2 cos cos. So 2 cos, again cos, of which here it will be 3 theta plus 5 theta over 2. Then here it will be, okay, 3 theta minus 5 theta over 2. What will be our final result? Shall get sine theta plus 2 sine 4 theta dot cos of just theta, because cos of a negative is a positive cos. Like that. Then cos theta plus 2 cos 4 theta dot the cos of theta. What next are we going to do here? What next are we going to bring in here? What next are we going to bring in here? So we are now going to have, is there a factorizing? No. Okay, maybe what I can think of here is, what if I divide all through by cos theta? What if I divide all through by cos theta? Can that work for us? All right, good. So I think let's understand the meaning of this. It will now be sine theta plus 2 into. Now to apply a double angle here, that will be 2 sine 2 theta cos 2 theta. Like that. That's what I want to use. Okay. Could we be having a minus somewhere? Could we be having a minus somewhere? Okay. That. It gives us tan 3, not tan 5, by the way, here. It gives us tan 3 theta. Okay. So cos, I'm using double angle identities to put here. Cos theta over cos theta plus, okay, plus 2 oh, here we can factorize this. This can be factorized. I can leave it as 2 cos 4 theta cos 4 theta times the cos of theta. All right, good. So again, I want to apply, double angle in there. So this will be sine theta plus all right, so we've made a resolution to this. Some correction has been made. Now here what we're going to do, let's consider sine theta and sine 5 theta. And that's we're going to consider. And with that, I first of all correct like terms. So it will be sine theta plus sine 5 theta. It's because when you add this plus this, you get 6 divided by this, you get a 3. Can be a better option. So sine 3 theta over, right, over, okay, cos theta plus, I'm correcting like terms, cos 5 theta plus cos 3 theta. Okay, good. Now after apply factor formula on these two. Factor formula of this one will be 2 sine cos, like that, but of course plus sine 3 theta. Now in this first bracket, add the angles divided by 2. So this will be theta plus 5 theta will be 6 theta divided by 2 will be 3 theta. So I put it direct. Then here we have theta minus 5 theta will be negative 4 theta. Divided by 2 will be negative 2 theta. Like that. Down, I'm dealing with this and that. Okay, so it will also be 2 cos and again cos, but plus cos 3 theta. Okay, the first point you add, it will just be 3 theta. Here to be negative 2 theta. The next, let's collect or we factorize out the common factor. Common factor here is sin 3 theta brackets. What are we going to have? Sin 3 theta brackets, what are we going to have? We're going to have cos 2 theta plus, okay, 2 cos 2 theta plus 1. Then the common factor here will be cos 3 theta. Bracket, you're going to remain with the 2 cos 2 theta. Because cos of a negative angle is a positive, plus 1. Now realize that these ones here are similar. They are similar. Now I have sin 3 over cos 3, which will give us tan 3 theta. Then you can say quite easily done. Let's now move to another example. All right, so we have another proof, which is here. Sin a plus b plus sin a minus b over cos a plus b minus cos a minus b must give us a negative quote of b. So we shall say from still left hand side. So here we are using factor formula. A sin plus sin will give